Hello, welcome back to all of you in our most important question series of electrochemistry. Today we will discuss question 6. Let me read the question. The question is telling the quantity of electricity required to reduce 24.6 gram of nitrobenzene to what? Aniline. If the correct efficiency for the process is how much percent? 50%. Then further they are giving information. If the potential drop across the cell is 1.5 volt, how much energy is consumed? So this is our question. So in today's, from this single question, we are going to understand. First we'll understand the basic mole concept, and we will also know calculation of n factor, and third and most important, which generally students used to confuse, current efficiency concept, and last is what do you meaning by 1 Faraday. So these all 4 topics will be covered in this single question. So let's proceed our question. If you'll see, they are telling that nitrobenzene is going to convert into what? Aniline. So let's write the reaction. To save the time, I have already written nitrobenzene. This is a nitrobenzene. Reduction has been done and it's going to give you what? Aniline. So if first we have to calculate the n factor. So let's see how to calculate the n factor for this reaction. I am assuming the oxidation state of nitrogen is X here. So X, and how many oxygen are there? 2 oxygen. So 2 multiplied by -2. And one more thing that is a very important. If we talk about nitrogen, and this is what carbon. Nitrogen and carbon, who is more electronegative? Nitrogen. So if nitrogen is more electronegative, so he will acquire some negative charge. I don't know. But as a result, can I say this carbon part means this whole part is going to acquire what charge? Some positive charge, right? So that positive charge I will be writing what? +1. Why I written +1? Because only single bond is there. So I written X plus 2 into -2 plus 1 will be equal to what? 0. So after solving here, how much we can get? -4 plus 1, which will be equal to 0. So X value will be what? +3. So here we came to know the oxidation state of nitrogen is what? +3. This part. If we'll talk about again, I'm assuming let's oxidation state of nitrogen is Y. So I written Y plus now hydrogen and nitrogen is more electronegative, so he will get negative. So as a result, hydrogen will get positive. How many hydrogen? 2 into 1. Again you check, if you'll check very properly, nitrogen and carbon, who is more electronegative? Nitrogen. So this nitrogen will be having some negative charge, but this carbon will be having what? Positive charge. And how many bonds are there? 1. So how much positive charge? +1. So I written what? +1, and no negative or positive charge is there in molecules. So how much I will get? Y plus 3 will be equal to what? 0. So Y I got -3. So our work has been done. Means oxidation number is going to change from +3 to what? -3. Now what is the n factor? N factor is nothing. Change in the number of electron. So here +3 and here -3. So what is the difference between +3 and -3? That is 6. So exchange of electron is how much? Exchange of electron, that will be what? 6 electron. That only we tell us what? N factor. So we came to know n factor. So n factor for nitrobenzene is what? 6. And if we'll talk about aniline also, n factor is what? 6. Let's see which we have to utilize. Anyway, both values are same, so not a big issue. Now afterwards, current efficiency for the process has been given, and one more thing they are also telling, we are having 24.6 gram of nitrobenzene. So let's first calculate the mole. So first thing, number of mole. They are giving directly telling 24.6 gram of nitrobenzene. So given mass is what? 24.6. So let me write for your more clarity. We are talking about nitrobenzene. So given mass by molar mass. What is the given mass? If you check, that is what? 24.6. What is the molar mass? For molar mass of this will be 1, 2, 3. You can check it. This whole, when you will calculate, it will come 1, 2, 3. You can check it. So molar mass 1, 2, 3, 24.6 divided by 123, it will come 0.2 mole. Calculation part, you can do it. So 0.2 mole came. Now what is the one thing you need to know? 0.2 mole of what? Nitrobenzene. 0.2 mole of nitrobenzene. So we can check it. Our nitrobenzene, what is the n factor? 6 only. So can I write reduction is taking place? So can I write gain of what? 6 electron, because we know reduction means what? Gain of 6 electron. So that's why I written +6 electron. So okay. So I can write 1 mole of nitrobenzene having 6 mole of electron. 6 mole of electron is nothing. Will be equal to what? 6 Faraday. So we came to know 1 mole of nitrobenzene 6 Faraday. But tell me how much mole of nitrobenzene is there? 0.2 mole. So I can write in the same way 0.2 mole of nitrobenzene will be equal to what? 6 multiply by 0.2. So how much I am going to get? 1.2 Faraday. So what I came to know कि 1.2 Faraday charge is flowing for how much mole of nitrobenzene? 0.2 mole of nitrobenzene. After this, current efficiency concept will come into the existence. So I can write current efficiency concept for 100% efficiency. How much? 100% current efficiency. For 100% current efficiency, how much Faraday? 1.2 Faraday. 1.2 Faraday charge is utilized for 100%. If 100% current efficiency is there, so 1.2 Faraday charge will be utilized. But in examiner has given how much percent efficiency? 50% efficiency. So let's check. They are talking about 50%. So what we can do? This is very important. This point, they have given current efficiency 50%. So if that is the case, so one thing which you need to know, current efficiency is inversely proportional to charge, because this is the only part where you will confuse. करंट इफिशिएंसी इज इनवर्सली प्रोपोर्शनल टू चार्ज. खुद ही आप सोचो, अगर कोई चीज़ 100% इफिशिएंट है और आपको चार्ज कितना मिल रहा है? 1.2 फैराडे. तो खुद ही सोचो, जब वो 50% इफिशिएंट होगा, मतलब उसकी इफिशिएंसी कम हुई. तो जब उसकी इफिशिएंसी कम हुई तो ज़्यादा चार्ज की जरूरत पड़ेगा या कम? इफिशिएंसी कम हुई है तो हमें ज़्यादा चार्ज की जरूरत पड़ेगी. मीन्स 1.2 फैराडे की वैल्यू क्या होगी? बढ़ेगा. कितना बढ़ेगा वो चेक करते हैं. सो यू कैन चेक इट. फॉर 100% इफिशिएंसी 1.2 फैराडे. सो फॉर कितने परसेंट के लिए पूछा है? 50%. 50% current efficiency, what I can write? 1.2 Faraday. You know कि now this 1.2 Faraday is going to increase. तो आप खुद ही सोचो, you will multiply by 50 or divide by 50%. You have to divide by 50%. 50% means what? 50 by 100, and 50 by 100 means what? 1 by 2. So directly I am writing what? 1 by 2. This is very important. Be aware. So 2 will go up. So you will be getting what? 2 to 4, 2.4 Faraday. So you can check it. जब हमारा करंट इफिशिएंसी 100 था तो 1.2 फैराडे. जब इफिशिएंसी कम हुआ है तो हमारा जो चार्ज है वो बढ़ गया है. मीन्स ये वाला फॉर्मूला हमारा अप्लाई हो रहा है. ध्यान दो, क्वेश्चन में बोल रहा है करंट और चार्ज में मैंने रिलेशन नहीं लिखा है, क्योंकि आप बोल सकते हो कि सर Q इज इक्वल टू IT भी तो होता है, तो यहाँ पे तो चार्ज और करंट डायरेक्टली प्रोपोर्शनल है. आपने इनवर्सली क्यों लिखा है? यहाँ पे क्वेश्चन में करंट इफिशिएंसी की बात कर रहा है और करंट इफिशिएंसी और चार्ज में इनवर्स प्रोपोर्शनल है. अब द मोमेंट यू हैव डन दिस, नाउ दिस क्वेश्चन इज सिंपल ईजी. सो थर्ड पार्ट, थर्ड सेगमेंट. अब third segment we can solve it very properly. Now already we know what is the formula for potential difference denoted by V. हम फिजिक्स में पढ़ते हैं वर्क डन टू ब्रिंग अ यूनिट पॉजिटिव चार्ज फ्रॉम इन्फिनिटी. सो V इज इक्वल टू व्हाट? W by Q. सो व्हाट आई कैन राइट? वर्क डन विल बी इक्वल टू व्हाट? पोटेंशियल इनटू चार्ज. तो 50% इफिशिएंसी के लिए हमारे पास कितना चार्ज है? 2.4 फैराडे. और वोल्टेज कितना दिया है क्वेश्चन में? इन क्वेश्चन हाउ मच वोल्टेज हैज बीन प्रोवाइडेड टू अस? दे हैव गिवन हाउ मच? 1.5 वोल्ट. जस्ट पुट द वैल्यू एंड गेट द आंसर. So I'm going to put the value. So voltage is what? How much? 1.5 volt. And charge is what? 2.4 Faraday. अब you already know 1 Faraday. 1 Faraday का मतलब क्या? Flow of 1 mole of electron. Means अगर कोई वायर है, if in that wire 1 mole of electrons are flowing, उसी को बोलते थे 1 Faraday. तो 1 Faraday means what? 96500 coulomb per mole. So Faraday if you want to remove, so what I can write? 96500. Now this part calculation when we will do. So after calculation it will come approx 347400. Calculation part you can do it. It will come in joule, and if you have to convert in kilojoule you have to divide by 1000. So it will come how much? 347.4 kilojoule. That is your answer. So that is your answer. Be aware. Let me just give a snap revision. Examiner was asking we have to calculate how much energy is consumed. For that purpose, current efficiency they were giving 50%. So first we have gathered the knowledge about n factor, where I have told nitrobenzene where he is accepting 6 electron becoming aniline. So I calculated +3 -3. Just I took the difference. +3 to -3 डिफरेंस कितना होगा? 6 इलेक्ट्रॉन. तो यही है n फैक्टर किसका? नाइट्रोबेंजीन का. देन मैंने मोल निकाला. वी हैव कैलकुलेटेड द मोल ऑफ नाइट्रोबेंजीन. देन आई टोल्ड कि 1 मोल ऑफ नाइट्रोबेंजीन 6 फैराडे. So 0.2 mole, 1.2 Faraday. Then current efficiency, very important concept. For 100% current efficiency, how much charge? 1.2 Faraday. So I given one information, current efficiency inversely proportional to charge. Then for 50% it is what? 1.2 divide by current efficiency I have divided. So 50% means 1 by 2, I got 2.4 Faraday. Now this formula I written work done is equal to potential into charge. Potential already given in question. And if we'll talk about charge just now we have got 2.4 Faraday. So 2.4 लिखा, Faraday की value 96500 है, so coulomb में आ गया. Then we have calculated unit will come joule only because volt and coulomb multiplication joule will come, then convert into kilojoule. So this was your question. Thank you so much. I will upload more questions based on JEE Mains and NEET. Thank you so much.